Hi friends, so today I begin Math Question Bank 10 and I'm going to discuss 5 questions and then solve these questions. Now these questions are going to be useful for you if you are planning to ask them to candidates applying for jobs in STEM subjects or in university admissions and college admissions. I'm Dr. Ganguly. So let's start with the first question, and this is essentially you are asked to solve for x. The equation here is sin x plus cos x equals 1. And the solution you need to find is within the range x is 0 to 2 pi. So of course you know that these kind of trigonometric equations, they are going to have a plethora of solutions, but this bound essentially restricts the number of solutions you need to find. So let's try to solve this problem. Now when we look at this problem, we will immediately realize that if we were to square both sides, then we are going to get a familiar identity, that is sin square x plus cos square x equals 1. So let's do that. Let's take this equation and square both sides. So of course the right hand side doesn't change, it remains 1. The left hand side becomes sin x plus cos x square. Now you know the formula that a plus b square is a square plus 2ab plus b square. So we can use that formula here. So you get a sin square x term, you get a 2 sin x cos x term, and you get the cos square x term. Now immediately we can use the fact that sin square x plus cos square x equals 1. Therefore the 1 here and the 1 here will cancel out, and what you are left with is 2 sin x cos x equals 0. But do remember that sin 2x is equal to 2 sin x cos x. This is from trigonometry, and so we immediately get the equation that sin 2x equal to 0. Now, of course, you know that the sine function, it has many zeros, and within the range which has been given, that is 0 to 2 pi, you are going to have the possibility that sine 2x is going to be 0. That of course satisfies this equation, or rather 2x equal to 0. And then the next one would be 2x equal to pi. So again sine would be 0 here, and again at 2 pi sine would be 0. If you are not particularly sure about this, look at some plots of the function sine, and you can also check it out on your calculator in the phone or any other place. So essentially if 2x is 0, pi to pi, we can immediately write that x is going to be 0, pi by 2 and pi. So I simply divided these values by 2. Now it's important in any equation solution to actually check whether the equations or the solutions you have obtained will satisfy the equation. So let's do that. Let us plug these three values in the equation here. So I start with 0. So let's put sine 0 plus cos 0. That of course is 1 because sine 0 is 0 and cos 0 is 1. Let's put pi by 2. So sine pi by 2 plus cos pi by 2 is 1 because sine pi by 2 is 1 and cos pi by 2 is 0. Now let's put the value pi. So we get sine pi plus cos pi. This is 0 plus minus 1. This is actually negative 1. So this will not satisfy the equation here. Now why this has come out as a solution is that we were actually solving the squared equation. So you will see that this satisfies the equation here. That means if we were to square this, of course it would be equal to 1. So whenever we square an equation, we get something which is known as an extraneous root. Sometimes it's called a superfluous root. Typically US people call this extraneous root and UK people call it superfluous root, but whatever be the fact, the thing to consider always is that whenever you are squaring any equation, you are going to introduce more solutions, so you need to check for that. Now let's check another problem, and this problem is a triangle, and in this triangle we see that we have the angle x here, the angle 2x here, this length is 8, this length is 2, there is a right angle here, this height is b, and these sides are c and d. So the question here is that you need to find b, c, d. The information which is of course given here is that this length 8 and 2 are given, and the angles x and 2x are given. Now very often these kind of problems are very useful to ask in different interview situations because they do check on a person's capability of linking different kind of thinking, for example, geometry and trigonometry. So I'm going to solve this problem largely using trigonometry, and there are of course some people who will like to solve it using geometry. If you are one of those people, please leave in the comment section how you would do that. So how I did this problem is that I essentially got sine x, which would be b divided by c, cos x, which would be 8 divided by c. These are from the basic definitions of the trigonometry function. So you are checking out the student's capability of remembering these things. Sine 2x would be b divided by d, and cos 2x would be 2 divided by t. So remember that any time you have a function like sine x, it is going to be the opposite side divided by the larger side in a right angle triangle, and cos is going to be the adjacent side divided by the larger side. So with these here, I can immediately invoke a number of trigonometric identities. So one of them, of course, I get is that sine square x plus cos square x is 1. So that immediately is going to give me b square plus 8 square is c square from these two equations here. Now, this is an interesting fact to keep in mind that these identities such as sine square x plus cos square x equal to 1, these are actually nothing but the Pythagoras theorem. So you could have got it directly here also by applying the Pythagoras theorem, that is b square plus 8 square would be c square. Now let's look at the second one here. That would give us sine square 2x plus cos square 2x equal to 1, or this is essential to using the Pythagoras theorem on this triangle. So that gives us b square plus 2 square is d square. So these two are the representations of Pythagoras theorem. These are simple, but we actually need more equations because we have b, c, and d, and here we have only two equations. So let's try to get some more equations. So of course we know sine 2x is this particular equation here. That's the expansion of sine 2x to sine x cos x. So I can plug in these values and I can write b by d, which is sine 2x, equals 2 into b by c, 8 by c, which is sine x into cos x. And then I cancel these two b's here and I land up with c square equals 16d. Now I am putting all these important equations in pink because we are going to solve them later. Now the next equation I get is cos 2x is cos square x minus sine square x, and I can immediately substitute these to get 2 by d equals 8 by c square minus b by c square. So again, if I expand this out, I can see that I will get 64d minus db square is 2c square. So what I did is I squared both these terms. I took the c square to the left hand side here. I multiplied by 2. So you get the 2c square term here. And here you get 64 into d. And here you get minus b square into d. So this is the fourth equation. So now with these four equations which I have put in pink, let's try to solve these for these different variables. So let's start with this equation, 64d minus db square equals 2c square, and instead of c square I put 16d here from this equation. So what I get is 64 minus b square is 32 because the d cancels out here. Of course d is not equal to 0. So from this I can immediately write that b is square root of 32, which gives me 4 into root 2. Remember 32 is 2 into 16. So now I have got B. So let me try to now get C. So we are proceeding with B, C, and D. So to do that, let's look at the Pythagoras equation, that is B square plus 8 square is C square. So this is going to immediately give me C is root of 32 plus 64. So the fact that B square is 30 root 32 is something I'm using here. And of course, b is root 32, so b square will be 32. So I get c is root 96, which becomes 4 into root 6. So essentially now I have got two of these. I have got b, I have got c. And so now I'm going to try to get d here. So I've got b square plus 2 square is d square. And so I get d is root 32 plus 4 here. So I solve this to get 6 here. So you see that I could find all the sides of the triangle and also this particular length. by using only trigonometry here. Now, there are people who can use some knowledge of geometry here, like maybe congruent angles, maybe similar triangles, and so on. All those things are possible, but maybe you do not remember geometry. You can do this completely by trigonometry. Now, let's come to question 3, which is another favorite of many people, and that is find the rank of this particular matrix. Now, in a previous lecture, I discussed the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rank of that matrix was 2. Go back and look at some of my earlier videos on this math question bank series. Now, in this problem, what you do is you simply change the 9 here to a 7. So the way to remember is you write 1, 2, 3, 4, 5, 6, and the 787, remember, is the Boeing Dreamliner. So this is essentially a plane. That's how kind of I remember it. Your mileage may vary. So let's try to find the rank of this matrix. So to find the rank, of course, you could take the determinant and show that that's going to be 0. That works in this problem because it's a 3 by 3 matrix and it's a simple way to do it. Some people are going to do it and that's fine. But we are going to use the more general method of putting this particular matrix in the so-called echelon form, which is that I'm going to try to get this triangle of zeros here, and then that's going to tell me about the rank of this matrix. So to do that, I first use the operation R2 is R2 minus 4R1. So here R stands for the row. So essentially what I'm doing is I am using that here. So again, take a look at R2 here. If you subtract 4R1 from that, of course, the term 4 becomes 0. That was the reason I selected this particular R2 minus 4R1 is I want to drive this first term here to 0. And so once I do that, the remaining terms you can calculate. So this is going to become 5 minus 4 into 2. So that's how you are going to get this term here and so on. So again, 5 minus 8 is going to be minus 3. And then you are going to get 6 minus 4 into 3, that is 12. So that's going to be minus 6. And so this last row remains same. Now I want to put this 7 term to 0. So what I do is I create R3 is R3 minus 7R1. So that gets me a 0 here, and here it's going to get me, of course, R3 is 8 minus 7R1. So 8 minus 7 into 2. So 8 minus 14, and that gives me minus 6, and here I get minus 14. Now the next step I should choose so that this minus 6 becomes 0, and that is selected like this here. R3 is R3 minus 2R2. So when I do that, this term is going to be 0 because R3 is minus 6 and I'm subtracting twice into minus 3 from that. So that is going to wash this out. Now when I apply it to this term also, you will see that this term will now remain a non-zero term. So essentially you have this R3 value here and you subtract 2 into minus 6. So you are left with minus 2 there. So this is the echelon form. I have obtained the triangle of zeros, and now I know from the definition that the rank of the matrix is going to be the number of non-zero rows in this echelon form. So you can see here that there are 3 non-zero rows in this echelon form. So the rank of this matrix is 3. Now this is a very popular question out there. So do remember this particular problem if you are a student or even if you are a teacher. Now let's come to question 4, and this is a third which is very popular because I think it was asked in one of the Math Olympiad problems, and many a time teachers and people take these problems and they recycle it in their exams or their tests and so on. So that's one good place to select problems that is very useful. So again, you know that these kind of surds were very useful and important when you were studying high school. And one of the advantages of asking these type of questions is that nobody can say that I don't know these things, or I didn't study these things, or maybe I don't remember these things, because this solution is going to rely on very simple algebra, and it's also going to test the meticulousness of the student, which is something which is very much required whether you are trying to do research, whether you are trying to do programming, and so on. So let's solve this problem. And to do that, what I will do is I will immediately put a is 1 plus root 3 and b is 1 minus root 3. So that's going to at least simplify my expression. We now know this is going to be a8 or a to the power 8 plus b to the power 8. And now I can see I will get some solutions out of what is AB and what is A plus B. And what I'm going to try to do is I'm going to try to get A to the power 8 plus B to the power 8. And I'm going to slowly build up there from using the fact that I may know A plus B square and so on. So let's start with this AB. So AB you know is 1 plus root 3 into 1 minus root 3. And then I can use the algebraic formula about A plus B into A minus B. So I will get 1 square minus root 3 square. So that is 1 minus 3. So AB is simply minus 2. Again, I put it in pink because we are going to use this equation repeatedly. Now I do a plus b, and a plus b is going to simply give me 2. So you see here a plus b, the plus root 3 will cancel out with the minus root 3, and I'm going to get 2. So now I turn to the well-known fact that a plus b square is a square plus 2ab plus b square. And so I can write a square plus b square is a plus b square minus 2ab. So I know a plus b was 2, so this would be simply 2 square, that is 4, and minus 2 into minus 2, so that gives me 8 here. Now the next thing I do is I go to a square plus b square and I square it, and that's going to give me a4 plus 2a square b square plus b4. So again I have applied this formula here, and I have simply thought of the a as a square and the b as b square. So this is the well-known algebraic formula. So from this formula I can then write that a4 plus b4 is going to be a square plus b square square minus 2a square b square. And now I know a square plus b square, that was 8. So 8 square is 64 minus 2 into ab square, and ab I know is minus 2, so it's minus 2 square. So it's 64 minus 8, and so that gives me 56. Now the last step is a4 plus b4 square is a8 plus 2a4b4 plus b8. And so now we are nearly there. We are getting a8 plus b8. So a to the power 8 plus b to the power 8 is going to be a4 plus b4 square minus 2 a4 b4. So again a4 plus b4 was obtained here, that was 56. So I get 56 square minus 2 into minus 2 to the power 4, and that gives me 3104. So you can see that this is not a very difficult problem, but it does test two things. It tests a basic knowledge of your capability to think in terms of different variables, to use a very simple formula, which is that a plus b square is a square plus 2ab plus b square, and also one more formula that when you have a plus b into a minus b, that gives me a square minus b square. So we can get this number here, and that's very satisfactory. You can check it out on your calculator on your phone if you want. Now the final question is question number 5. This was actually posed by Ramanujan, at least that's the theory which is out there everywhere. So let us look at it. Maybe he was bored and he was thinking about some easy problem and he came up with this problem. So it's root x plus y is 7 and x plus root y is 11, and x, y are positive integers. So this is the problem we need to solve. So let's try to solve this problem. We write this problem here in red, and then I'm going to define a is root of x and b is root of y. So this is going to simplify my life. Now there are some people who like to carry on this problem with root x and root y. It's possible, but one of the advantages of doing it like that is that we get equations which we are used to. So then I can immediately write this equation as a plus b square is 7. So remember that root x is a and b is root y. So y is going to be b square. Also I get the second equation as a square plus b is 11. So again remember x is going to be a square and root y is b. So these are the two equations, and what I do now is I simply try to change these equations or get more out of these equations. And one of the things I can realize is that I can subtract these two equations, and that may make the left hand side more amenable to factorization. So I do that. So in that case, I would get a square plus b minus a minus b square is 4. So I have taken this equation, and from that I have subtracted this equation here. Now this equation gives me the idea that I could get the term a minus b out as a common term. So I could write this as a square minus b square and minus a minus b. So you can see here this term will be minus a, this term will be plus b. So this equation is here, and then I can take a minus b out, and then I get here a minus b. So essentially I have factorized a square minus b square into a minus b a plus b, and this is also a minus b. So now I get the a minus b out, and I get a plus b minus 1. So that is the factorized equation. Now when I look at this equation, I know the right hand side is 4. So since these are all going to be positive numbers and so on, I can say that what's going to happen, this is going to be 4 into 1 or 1 into 4 or 2 into 2. So we are going to investigate these possibilities and see what goes on there. So the first possibility is a minus b is 4 and a plus b minus 1 is 1. So that's the possibility here. So in this case, let me add these two equations, because then the b would cancel out. So what I do is I get 2a minus 1 is 5, which gives me a is 3 and b is minus 1. Now this looks like a legitimate solution. I could square them and I would get x is 9, y is 1. But if I were to substitute it here, it would not work out. So you can see here this would be root of 9, that is 3, plus 1, that would not be 7. So actually this is an extraneous root and we remove this. The second solution I could get is a minus b is 1 and a plus b minus 1 is 4. And this case gives me, if I add these two equations, 2a minus 1 equals 5, a is 3, b is 2. Now here I can immediately square these values and I will get x is 9, y is 4. And here if I substitute it here, I can see this is quite good, because here I would get root of 9 is 3. So 3 plus 4 is 7. And again here I get 9 plus root of 4, or 9 plus 2 is 11. So this is a satisfactory solution, and this is the solution. Actually, if I now take the case 2 and 2, I would get a minus b is 2, a plus b minus 1 is 2. And so let me add these two equations. So I get 2a minus 1 is 4, a becomes 2.5, b is 0.5. Again, if I square them, it's also going to be something which is related to the real number space. So these are essentially numbers which contain decimals, so they are not integers. So again, these two solutions in pink are not satisfactory solutions, and the solution here is x equal to 9 and y equal to 4. Again, this is quite a popular question as far as various interviews are concerned. It's a good warm-up question, but you will be surprised that many people are actually not able to solve these questions. So this is a good way of filtering out people in case you are looking at their very basic math capabilities. So that was my question bank for today, and I hope you enjoyed this question bank. This is something which is amenable to people even at the high school level. I try to keep the problem such that the problems do not require too much extra knowledge beyond high school, because then what happens is that people may not always remember those things, and so it may come across that you are asking questions which are too hard for an interview setting or for a preliminary test. So that's something you need to always keep in mind, that you can use basic concepts in algebra, in geometry, in calculus to create problems which are actually very difficult to solve when people are in front of a whiteboard or in front of a blackboard.